Hello and welcome. Today, we're going to unlock the secrets behind, well, pretty much everything that moves. From a massive planet orbiting the sun, all the way down to a soccer ball rolling across a field. So, let's dive right into the fundamental rules of our universe, Newton's laws of motion.
Have you ever really stopped to think about it? Why does a ball eventually stop rolling? Or why is it so much harder to push a heavy box than a light one? And how in the world does a rocket actually launch into space? Believe it or not, these aren't just random events. They all follow a very specific and surprisingly simple set of rules.
And the genius who cracked this code way back over 300 years ago was Sir Isaac Newton. He gave us 3 laws that became the absolute bedrock of physics. So let's break them down one by one.
Okay, first up we have the law that really sets the stage for everything else. It's usually called the law of inertia, and it's all about how objects have this natural tendency to just, keep doing whatever they're already doing.
So Newton's first law puts it like this. An object at rest remains at rest, and an object in motion remains in motion, unless acted on by an unbalanced force. The big idea here is that things are perfectly happy to stay just as they are. They only change what they're doing, like starting to move, stopping, or turning, when something from the outside comes along and pushes or pulls on them.
And that resistance to change, that's what we call inertia. Honestly, you can almost think of it as an object's laziness. And the more mass an object has, the more inertia it has. That means it's lazier, and it's a lot harder to get it moving, or for that matter, to get it to stop.
We see this inertia all around us, every single day. That book sitting on your table, it's not going anywhere on its own. A soccer ball wants to keep rolling forever, but friction from the grass is that unbalanced force that slows it down and eventually stops it. And get this, an astronaut floating in deep space will just keep drifting in a perfectly straight line, basically forever, because there's nothing out there to stop him.
All right, let's build on that and move to law number 2. If the first law is about what happens when there's no force, the second law is all about what happens when there is a force. This is the math that tells us exactly how to change an object's motion. This one is famously boiled down to that little equation. F equals ma, force equals mass times acceleration. It's this beautiful, simple formula that connects 3 really important things: how hard you push something, how heavy that thing is, and how quickly its motion changes as a result. Now let's be super clear about what we mean by acceleration. It's not just about speeding up. In physics, acceleration is any change in velocity. So yeah, that means speeding up, but it also means slowing down, or even just changing direction. So a car that's turning a corner, even at a constant speed, is absolutely accelerating. This table breaks it down perfectly. You want to make something accelerate more? Well, you've got 2 options. You can either push it harder, increase the force, or you can make it lighter, decrease the mass. It's the reason you can throw a baseball way faster than a super heavy bowling ball, even if you use the exact same amount of effort. And that brings us to the third and final law. This one is so simple, but it's also incredibly profound. It tells us that forces never ever act alone. They always come in pairs.
Now really listen to these key words: equal and opposite. For every single action, there is an equal and opposite reaction. This is a universal rule. It means you literally can't touch anything without it touching you back with the exact same amount of force.
Think about a rocket launching. It's not pushing off the ground to fly. No way. It's pushing hot gas down. That's the action. And what happens next? The gas pushes the rocket up. That's the equal and opposite reaction. It's the same thing when you're swimming. You push the water backward, and the water pushes you forward. Every single interaction is a two-way street. So, there you have it. These 3 laws aren't just some abstract ideas for a textbook. They are a powerful, practical toolkit that you can use to understand and even predict how the whole physical world works. So, let's recap the whole thing in a nutshell. 1. Objects are basically lazy. They resist any change in their motion. 2. If you want to change an object's motion, you've got to apply a force, and how much it changes depends on how heavy it is. And 3. Every single push has an equal and opposite pushback. Simple as that. So, from now on, when you see a car turning a corner, or a bird taking flight, or even when you just feel the solid ground under your feet, think about these laws. Now that you know the rules of the game, can you start to see them playing out literally everywhere you look?